body when said to rotate about a fixed axis we consider, and that axis is called as rotational axis, and the body is undergoing rotational motion. The best example, if in case if I happen to give you the earth rotating about its own axis or a spinning top. A top when made to spin about a given axis, students. Now, when I speak about certain terms related to rotational motion, students, so as if you are aware about it, okay? You have theta, we consider is the angular displacement, students, which is measured in radians, okay? Omega is angular velocity, we consider, and that is all of you all are aware about it, radians per second. And this omega can be written in terms of d theta by dt. We consider for non-UCM students, non-uniform circular motion, or if I say non-uniform rotational motion also we can consider for the entire body, entire system. Whereas I can write an omega as simply theta by t, which can be written as 2 pi by capital T, which is equal to 2 pi f. And that is for uniform circular motion, students. So that's omega we can consider. It's a vector quantity. Then we write down in terms of your next relation we consider is angular acceleration. Angular acceleration is simply rate of change of angular velocity with respect to time. So it's omega 2 minus omega 1 upon students. अब तक हम लोग ने MCQs इसके ऊपर किए नहीं है. But who knows, they might ask you omega 2 minus omega 1 upon T2 minus T1. So alpha can be written as omega 2 can be written as 2 pi into bracket F2 minus F1 upon T2 minus T1. Whereas over here, this is d theta by dt. Students, over here also we didn't do any questions based on to that. Theta 2, this can be written as theta 2 minus theta 1 upon T2 minus T1. ये सब ध्यान में रखना, students. Shayad I had given you one question onto this also. The change in angular displacement in the first second and the fourth second we consider. I gave you the two relations and we use kinematics for this. So do take care, students. Theta 2 minus theta 1 upon T2 minus T1. The formula for theta in terms of number of revolutions and number of rotations, students, do keep in mind. Theta is equal to n into 2 pi, where n stands for number of revolutions and number of rotations. Hope this part is all clear, which is told to you earlier also, students. So theta is angular displacement, omega is angular velocity, alpha is angular acceleration we consider. Now when I say agar omega constant hai, students, omega agar constant hai, तो वो UCM हो जाएगा. नॉन UCM में ओमेगा कांस्टेंट नहीं है. अगर UCM है तो अल्फा 0 हो जाएगा. नॉन UCM में क्या होगा? सर यहाँ पे d omega by dt है तो omega 2 minus omega 1 होगा, and that is angular acceleration we consider. Now when I get the formula for angular acceleration we consider, then you have your angular momentum. Angular momentum is given by the formula. Can you give me the angular momentum in correct vector rotation? Students, listen carefully. Angular momentum in correct vector rotation. Now let us go back to this part of it. We are going for rotational motion. Students, please pay attention. Suppose अगर मैं कोई spinning top तुम्हें देता हूँ, think as if this is spinning top. Okay, the top has its own axis of symmetry. ये है spinning top. और ये उसका axis of rotation है. Am I getting it? And this particular top has a pointed end at the bottom. And the entire top is set to rotate about this axis. Now, suppose if I happen to put a red dot on this particular top, friends, if I happen to put a red dot on this particular top, when the top is set to rotate about the given axis, when the top is set to rotate about given axis, students, so the top is performing what kind of motion? The top is performing rotational motion. But what about this particular point, the reddish point? This point P I'll consider is performing circular motion. Do keep this in mind. Absolutely correct, Parthy. अगर suppose students ध्यान से सुनना, अगर suppose मैंने बोला कि the top is performing, listen carefully, students, pure rotational motion. Pure, yes, Sanjana, pure rotational motion. If I say go for pure rotational motion, का मतलब क्या? omega is constant. Please, ye ध्यान में रखना students. The top is performing rotational motion with constant angular velocity, students. Angular velocity is kept constant in this case. So what about this particular particle or the red dot? It's performing uniform circular motion. Students, यानी जब भी तुम रोटेशनल मोशन करते हो और वहां पे अगर वर्ड प्योर आया, pure rotation motion, that means the body is performing equal number of revolutions in given time. The number of revolutions performed by this particular particle, or the number of rotations performed by the entire spinning top, remains constant, students. Now, if I ask you what exactly the relation for angular momentum we consider. So when I speak about for a body set to rotate about a given axis, students, how are the particles? Then let us say, students, let us say that this becomes my plane of revolution. Please, students, try to understand this. ये है मेरा क्या plane of revolution, यानी अगर मैं ये red dot को देखूं, students, please pay attention. Can I say my red dot is actually, this is my plane of revolution? Like that, I can go for sections inside it. So इसमें अलग-अलग sections ले सकता हूँ. ये हुआ दूसरा plane of revolution. ये हुआ दूसरा plane of revolution, है ना? तो ये अलग-अलग plane of revolution है. अभी मैंने red dot यहाँ पे रखा है. So let us go for this red dot. तो अगर ये पूरा spinning top rotational motion कर रहा है, students, so can you tell me what about the red dot is performing? Yes, it's performing circular motion, है ना? अगर ये प्योर रोलिंग रोटेशनल मोशन है, यानी ओमेगा कांस्टेंट है, तो ये यूसीएम हो जाएगा. ये जो रेड डॉट है वो क्या परफॉर्म कर रहा है सर? इट्स परफॉर्मिंग सर्कुलर मोशन अबाउट द सेम एक्सिस. ये देखो, ये रोटेशनल एक्सिस है, तो ये है एक्सिस ऑफ रेवोल्यूशन व्हिच रिमेन्स कांस्टेंट. Now if I want to ask you students, how is the entire system is rotating? The entire system is set to rotate in anti-clockwise. The entire system, look at my, if I hold my spinning top and if I'm rotating it, see my thumb is pointing upwards, it's going in anti-clockwise. So what about this particular point is also revolving anti-clockwise direction. So agar ye anti-clockwise direction is, students, so can you tell me, this is the center of the circular path, this becomes the position vector, agreed? Where exactly the tangential terms are? So the tangential terms are along the tangent and they'll be along the y-axis. And agar maine isko horizontal x-axis le liya, students, if I take this as horizontal x-axis, this becomes my y-axis. My axis of rotation is my z-axis, students. So where are all the tangential terms are? So all the tangential terms, that means linear displacement, linear velocity, linear acceleration or tangential acceleration, linear momentum, linear force, all are acting along which axis? Y-axis. Where exactly angular terms are, students? Where exactly angular terms? All are along positive z. यानी कौन सा है? Angular displacement, angular velocity, angular acceleration, angular momentum, and torque. We'll be going for concept of torque also. ये पॉजिटिव z एक्सिस है क्योंकि बॉडी काउंटर क्लॉकवाइज में है. अगर क्लॉकवाइज होता तो इट विल गो इन द डाउनवर्ड डायरेक्शन. क्या इतना क्लियर हुआ स्टूडेंट्स? इज दिस मच क्लियर?
यस सर.
Yes, sir.
नाउ ट्राई टू, प्लीज अभी ध्यान से सुना स्टूडेंट्स. अभी हम क्या करते हैं, हम अलग अलग पार्टिकल्स को लेते हैं. स्टूडेंट्स मुझे बताओ, ये एक पार्टिकल यहाँ पे था स्टूडेंट्स, और अगर सपोज एक पार्टिकल को मैं यहाँ पे लेता हूँ, प्लीज पे अटेंशन है, एक पार्टिकल को मैं यहाँ पे लेता हूँ. लेट अस से आई एम डिस्क्राइबिंग दैट. नाउ दिस इज 1, दिस इज 2, द थर्ड वन इज ओवर हियर. मुझे बताओ, which one is performing circular motion? Out of 1, 2 and 3, which one are performing circular motion? With the spinning top is performing rotation motion. Point
So
1.
all,
The
so
third
1 and 2
one.
are performing.
Yes, the third one. Look at, where is the third one? Students, is it clear? Is the board work clear? Are you able to see it clearly, students?
So
Yes,
the third one is on the axis of rotation. So torque is equal to 0.
So students, all those points which lie on the axis of rotation do not revolve at all. They are along the fixed axis, students. They are on the axis of rotation, students. So there is no effect onto it we consider. Yani तुम्हारा 1 and 2 are performing circular motion. So the students, the 3 is always we consider to be about that same point. It's an axis. It's always at rest, I'll consider to be in comparison to the rest. All the other particles are revolving about a given axis we consider. Now, if we compare, the answer is, if we compare 1 and 2, have a look at 1. Is 1 closer to the axis or 2 is closer to the axis?
2 is closer to the axis.
So मुझे बताओ, what about the linear terms? Listen carefully, students. What about linear terms? And what about angular terms? For 1 and 2, does the magnitude, listen carefully, does the magnitude of the linear terms, that means which terms? Linear terms ka matlab which terms? The terms which are either along x-axis or y-axis. Does the magnitude of linear terms changes if I compare
Yes, sir.
them? Yes. So समझ में आ रहा है? एक point 1 is far away from the axis, point 2 is closer from the axis, 3 is lying on the axis. So students, what about the linear terms? Sir, linear terms 1 और 2 के अलग होंगे? कैसे? सर ये देखो ना, point 1 दूर है तो उसका पोजीशन वेक्टर का मैग्नीट्यूड ज्यादा होगा क्योंकि उसका ऑर्बिटल रेडियस ज्यादा है. सर point 2 आपने लिया है दूसरा प्लेन ऑफ रेवोल्यूशन. आपने ये स्पिनिंग टॉप को अलग अलग रेवोल्यूशंस, प्लेन ऑफ रेवोल्यूशंस में डिस्क्राइब कर दिया है. आपने अलग अलग प्लेन्स में ले लिया है और ये पार्टिकल 2 है लेकिन एक्सिस के नजदीक है, तो यहाँ पे उसका पोजीशन वेक्टर का मैग्नीट्यूड कम होगा. फेयर इनफ. यानी यहाँ पे रेडियस वेक्टर कम है, यहाँ पे रेडियस वेक्टर ज्यादा है, तो मैग्नीट्यूड इज चेंजिंग. तो ऑफ कोर्स देयर आर मैग्नीट्यूड आर चेंजिंग अलोंग द एक्स एक्सिस वी कंसीडर. अगर मैंने ओमेगा को कांस्टेंट रखा, स्टूडेंट्स, अगर मैं ओमेगा का, मुझे बताओ क्या एक्सेलरेशन सेंट्रीपिटल और फोर्स सेंट्रीपिटल के मैग्नीट्यूड भी चेंज होंगे? सर होंगे. एक्सेलरेशन सेंट्रीपिटल के फॉर्मूलास क्या है स्टूडेंट्स? एक्सेलरेशन सेंट्रीपिटल का करेक्ट रिलेशन इन वेक्टर माइनस ओमेगा स्क्वायर इनटू आर. What are its formulas in magnitude? In magnitude, so there are 3 formulas: r omega square, v square by r, v into omega. If I want to write on force centripetal, how many formulas are there for force centripetal? Mass into acceleration, mr omega square, mv square by r, m into v into omega. तो स्टूडेंट्स, अगर ये ध्यान से सुनना स्टूडेंट्स, अगर ये स्पिनिंग टॉप प्योर रोटेशनल मोशन परफॉर्म करता है, उसका मतलब ओमेगा कांस्टेंट है. अगर ओमेगा कांस्टेंट है तो सारों में ओमेगा कांस्टेंट है. लीनियर वेलोसिटी आल्सो आई कैन कंसीडर दिस केस. So now if I happen to go for its omega, students, acceleration centripetal will be r omega square. This is the formula I'm going to use. Force centripetal will be mr omega square, students. So in that case, what happens over here? Does the magnitude goes on changing? Yes. A particle which is far away and a particle is closer, students, magnitude of position vector will change. Magnitude of force centripetal will change. Magnitude of acceleration centripetal will change. मैंने क्या पूछा था? Linear terms. तो linear terms में one which is along x-axis सारे change होंगे. What about the terms along y-axis? Along y-axis, these are the linear terms along y-axis. Look over here. Is this particle far away? Yes, sir. This particle is far away. What's the formula? V is equal to r omega. If I happen to use V is equal to r omega, students, V is equal to r omega. Sir, इसका रेडियस सबसे ज्यादा है, तो इसकी वेलोसिटी सबसे ज्यादा होगी. क्या ये क्लियर हुआ? Students, क्या are you getting this? यानी अगर कोई entire object rotational motion परफॉर्म करता है, उसके constituent particles परफॉर्म करते हैं circular motion. अगर ये पूरा ऑब्जेक्ट प्योर रोटेशनल मोशन परफॉर्म कर रहा है तो बाकी सारे यूनिफॉर्म सर्कुलर मोशन कर रहे हैं. लेकिन यूनिफॉर्म सर्कुलर मोशन से व्हाट अबाउट द कंस्टिट्यूएंट पार्टिकल्स? उनके लीनियर टर्म्स सारों के अलग अलग होंगे. द मैग्नीट्यूड ऑफ लीनियर टर्म्स विल चेंज. व्हाट आर द लीनियर टर्म्स व्हिच आर गोइंग ऑन चेंजिंग ओवर हियर विल बी लीनियर डिस्प्लेसमेंट, linear velocity, linear acceleration, linear momentum, linear force, position vector, ये सारे change होंगे. Acceleration centripetal, force centripetal, ये सारे change होंगे. What remains constant? So all those terms along z-axis will remain constant. यारी students, angular terms हमेशा constant रहेंगे. Angular terms हमेशा constant होंगे. यानी students, जब भी कोई body rotate करता है, तो what about the constant particles? All those constant particles which are there, do they have different linear terms? Yes. What about the angular terms? Of all remains constant. क्या ये part clear हुआ for the concept related to rotational motion? Is this clear?
Yes, sir.
Rest of the students?
Sir,
Yes.
sir, but for the particles 1 and 2, the torque and the angular momentum would not be same, right?
Which one?
For the particles 1 and 2, sir, because they depend upon the magnitude of the radius vector, so they'll change, right?
Torque for the entire body is set to rotate. About this, if in case of if I speak about the torque acting on that particular particle, of course it's r cross f we consider. Corresponding, if r increases, the force has to be decreasing. यहाँ पे r decrease हो रहा है, तो force comparatively increase होगा. Product remains constant. इसी चलो, I'll give you the explanation for this. Who's raising this question? Sneha, you raise this question, na?
Yes.
स्नेहा, अभी ध्यान से सुन. पहले पार्टिकल का देख. पहले पार्टिकल का पोजीशन वेक्टर क्या है? लंबा है कि दूर है? Is it closer to the axis or far away from the axis?
Far away from the axis.
Okay, तो यहाँ पे comparatively tangential force कम लगेगा या ज्यादा लगेगा?
से कम होगा.
हाँ, और वही अगर पार्टिकल नजदीक होगा तो उसका पोजीशन वेक्टर कम है, तो उसको ज्यादा फोर्स लगेगा.
Yes, sir.
लेकिन दोनों का प्रोडक्ट in both the cases will remain the same.
Okay.
Getting it? Are you getting it? A simple example,
Yes.
students, we can consider is in order to have a turning effect, in order to have a better turning effect, that is, if I want to have the moment of force constant, of course, the product should be remaining same. If R decreases, F will increase. If F increases, R will decrease. Either case we consider. Hope this part is clear to the rest of the students also.
Yes, sir.
Okay, can you students, ये ध्यान में रखना, students, please pay attention. Whenever a body is set to perform rotational motion, students, all its constant particles are performing circular motion. If it's pure rotational motion, angular velocity remains constant. The particles are going to perform uniform circular motion. All the angular terms are acting along positive z-axis. For anti-clockwise motion, we consider all the linear terms. Tangential terms are acting along y-axis. There are terms along x-axis also we consider. The particles which are far away from the axis of rotation or revolution we consider. Okay. Then what about the linear terms? Varies with respect to those which are closer. How do you describe this? Now to देखो students. अगर suppose मैं यहाँ से एक imaginary axis pass करता हूँ students, ये देखो ये एक imaginary axis ले रहा हूँ और ये भी एक imaginary axis ले रहा हूँ, है ना? तो अगर मैं बोलूँ, ध्यान से सुनना, जितने particles ये axis पे होंगे ना, यानी देखो ये 1 है, अगर मैं यहाँ पे भी और एक particle लेता हूँ, because this is lying on. Students, ये जो पार्टिकल है 1 और ये जो पार्टिकल है, दोनों का डिस्टेंस एक्सिस से सेम है, तो दोनों के लीनियर टर्म सेम होंगे. ये भी ध्यान में रखना. ये और ये अलग अलग प्लेन ऑफ रेवोल्यूशन है. यानी all those particles lying, listen carefully to the statement, all those particles which are lying on the given axis and are equidistant from the axis of rotation, their linear and angular terms remains constant. Look at the another axis. ये axis देखो. अगर मैं यहाँ पे एक पार्टिकल ले लूं, स्टूडेंट्स, यहाँ पे एक पार्टिकल ले लूं, यहाँ पे एक पार्टिकल ले लूं, यहाँ पे एक पार्टिकल ले लूं, देखो ये पार्टिकल सारे इक्विडिस्टेंट है फ्रॉम द सेंट्रल एक्सिस. यस, तो उनके लीनियर एंगुलर टर्म्स कांस्टेंट ही रहेंगे स्टूडेंट्स. लेकिन इफ आई कंपेयर बिटवीन दीज टू पार्टिकल्स, Students, the linear terms, the magnitude linear terms will change, but their angular term remains constant. This is very, very important point to be noted for rotational dynamics. क्या ये क्लियर हुआ सबको? Is this clear?
Yes, sir.
Students, all of you are inside the group. Yana, Parthui,
Yes, sir.
Yes.
Yana, what about you? Okay, this is also getting it. Yes. What about Aditi, Janani, Sneha?
Understood, sir. Yes, sir.
Okay. Suhani, Soumya is there. Soumya, are you getting it?
Yes, sir.
Ranker, Aditi is getting it. What about Swati? What about Shreya, Pranshu? Okay, students, ये ध्यान में रखना students. This is for a rotating body we consider. ये तुम्हारे angular terms होंगे theta, omega, alpha. What is angular momentum? Sir, angular momentum I can write it in terms of r cross p. ये हुआ तुम्हारा angular. ये सारे angular terms हैं students. ये सारे तुम्हारे angular terms हैं. Getting it? Which a body we consider. अगर मैं torque लिखूंगा तो torque क्या होगा? वो भी angular term. These are all angular terms we consider. That is theta, omega, okay, alpha, angular momentum, torque. These are all your angular terms, students. Can I erase this now, students?
No, sir.
Since along with this, do keep in mind what about the rotational dynamics, what you use it over here, the rotational kinematics, students. So do keep in mind you have final angular velocity is equal to initial angular velocity plus alpha into t, students. ये सारे formulas ध्यान में रखना students, okay? Theta is equal to n into 2 pi. ये भी ध्यान में रखना है, बहुत important है. Many students misses out with this. यहाँ पे जब तो हम देखो, now suppose if I say angular displacement is equal to initial angular velocity into time, s is equal to ut plus
Half alpha t square.
yes. तो यहाँ पे theta को you can learn n into 2 pi. Students, there are questions based. They might ask you for rotational dynamics, a fan rotating. They can ask you find out the power exerted by the motor of the fan. And power is given by what formula I had given you earlier in rotational dynamics, students. Power, if in case you have learned about work energy power, students, so power is equal to F dot V we consider, force into velocity. It's a dot product. Are you getting it? Power is equal to F dot V we consider. लेकिन वो translation motion के हिसाब से जाएगा. तो F के जगह पे यहाँ पे torque आएगा. Linear velocity की जगह पे यहाँ पे angular velocity आएगा. So torque into omega. But again a dot product. Students, power is a scalar quantity. Work is a scalar quantity. Work is a dot product of F dot S. Power is a dot product of F dot V we consider. So do take care when you're solving questions based on these kind of rotational dynamics. Students. Then you have omega square is equal to omega naught square plus 2 into alpha into theta. Theta can be written as n into 2 pi. And this are put in vector notation, students. अब ये ध्यान में रखना स्टूडेंट्स, अगर बॉडी एंटी क्लॉकवाइज में जा रहा है, एवरीबॉडी इज केयरफुल, ये भी मैं बता चुका हूँ स्टूडेंट्स. अगर बॉडी एंटी क्लॉकवाइज में जा रहा है एंड द मोशन इज एक्सेलरेटेड, motion is accelerated, students, so the alpha is going to act along positive. because your final angular velocity is greater than the initial. Students, alpha का formula क्या होगा? How's alpha over here? Alpha is what? Angular acceleration, final minus initial upon t2 minus t1, radian per second square, radian upon second square. Students, अगर final angular velocity is greater than initial, तो alpha तुम्हारा positive होगा, anti-clockwise it's going in this direction. लेकिन अगर ये टॉप स्पिन कर रहा है, यानी परफॉर्म कर रहा है रोटेशन मोशन, और वो एंटी क्लॉकवाइज में मूव कर रहा है, लेकिन अगर उसका स्पीड कम होते जा रहा है, ध्यान से सुना स्टूडेंट्स, उसका स्पीड कम होते जाता है, then in that case, in spite of being in anti-clockwise direction, students, omega will be acting along positive z axis for anti-clockwise, but alpha, do keep this in mind, because your final angular velocity is less than initial, in spite of body rotating in anti-clockwise direction. And if the motion is decelerated or the motion is getting retarded, your final angular velocity goes on decreasing. It's less than the initial. Students, direction of alpha will be along negative z-axis. So what if the body is going in anti-clockwise direction? क्या ये clear हुआ सबको? Students, is this part clear to all of you all?
Yes, sir.
Yes, sir.
Please don't forget this. और ये मैं बहुत पहले बता चुका हूँ when I had discussed about it. I'd given about the blades of a ceiling fan, and I'd given you that explanation. If you happen to look at those particular lectures, or if you have noted down the points very clearly. So students, your circular motion and your rotation goes hand in hand. It's only that we have system of particles, because when you speak about system of particles, we are going with respect to center of mass. Over here, when you're speaking about rotational motion, we're speaking about center of gravity. The entire weight is supposed to be concentrated at that point. क्या मैं erase कर सकता हूँ students now? Students?
Sir, 1 minute.
Yeah.
Done, sir.
Okay. Now, these particular I've written over here as your correct vector notation, students. A body performing circular motion or rotation motion, students, do keep in mind about your right hand screw rule, students. So these are your important variables which you need to take care of it, and the correct vector notations you need to go for it, students. अगर मैं कोई body को revolve करता हूँ, students, in anti-clockwise direction, students. Okay, that is I, J, and K. Okay, students, then you can go about in terms of I, J, and K, students, in anti-clockwise. Then you have a relation of V, tangential, angular, torque, angular displacement, angular linear displacement. You're getting it? And acceleration centripetal. Students, can you give me a correct vector notation for a body moving in anti-clockwise direction? This is I, J, K. ये ध्यान में रखना, students. So can you give me a relation between V and omega and R? So V is along which axis? V is acting along J. So what exactly J, K cross I? Anti-clockwise है, students. ये सारे मैं anti-clockwise ले जा रहा हूँ. तो यहाँ पे V क्या होगा? Omega bar cross.
Omega cross R.
ये ध्यान में रखना. Can you give me acceleration tangential, students? I wanted a formula with respect to R and alpha.
Sir, alpha cross R.
Absolutely correct. Alpha cross R. Angular momentum for anti-clockwise direction. Angular momentum is acting along z-axis. That is K cap. And anti-clockwise K is equal to what? I cross J. So angular momentum will be equal to I
R
want
cross
it R cross P. Agreed. And P is equal to M into V. Therefore, angular momentum is MVR. So जहाँ पे क्रॉस प्रोडक्ट आता है कंपोनेंट साइन थीटा आएगा आएगा आएगा, ये ध्यान में रखना स्टूडेंट्स. Now, if I happen to go for torque in terms of force and position vector,
R cross F.
R cross F, because torque is acting along K cap, so I cross J. What about your displacement in terms of angular displacement and position vector?
Theta cross R.
Yes, it's theta cross R, because this is acting along what exactly considered as J cap. J is equal to K cross R. Acceleration centripetal. Students, acceleration centripetal. Suppose if I happen to go in terms of V and omega.
Sir, V cross omega.
Students, acceleration centripetal अगर मैं I cap लेता हूँ students, so it will be J cross K forward direction anti-clockwise. But अगर इसका मैंने direction change कर दिया, are you getting it? So what exactly I'll take it? Now see, if
K
I go for
cross J.
pardon? Yes. So now acceleration centripetal is given by what formula? I want in terms of V and omega. Students, V and omega vector forms in this
V
case.
cross omega.
Yes, it's V cross omega, which I told you very clearly. The correct representation of acceleration centripetal is negative omega square into. और जब भी स्टूडेंट्स तुम प्रॉब्लम्स करो एक्सेलरेशन सेंटीमीटर जहां पे भी ओमेगा कांस्टेंट आ गया यूसीएम आया है स्टूडेंट्स प्लीज गो फॉर दिस पर्टिकुलर मैथमेटिकल रिलेशन. आई गेटिंग इट? बिकॉज़ सी ओवर हियर देखो ध्यान से देखो स्टूडेंट्स यहाँ पे डायरेक्ट प्रोपोर्शनल आ रहा है. अगर तुम v स्क्वायर बना लोगे तो तुरंत तुम सोचोगे सर यहाँ पे तो इनवर्स है. डोंट गेट कंफ्यूज्ड व्हाइल सॉल्विंग क्वेश्चंस. Students, when they give you about planets revolving or any electron revolving and they give you the radius vector is changing in that case, students, but omega remains constant, we consider. Are you getting it? The time period for that particular particle remains constant in that case. In a given orbit, we can consider this. We can find out accordingly. So that depends on the individual. How do you go about with it? So is this part clear to all of you all?
Yes, sir.
Okay. Can I erase it now?
Yes, sir.
Okay. Okay, students. So now before going for a rotational motion, you need to know these particular basics, very important students. Now, when you speak about rotational motion, example, give you Earth rotating about its own axis, about its own axis or rotational axis, or a spinning top. I'd give an example. Rotational motion, students, is very well defined with what kind of object, students. We go for rigid object. हम rigid objects क्यों लेते हैं students? Why do we go for rigid objects to understand the concept of rotational motion? Students? Why not elastic? Why not plastic?
So
Why
they
do
may
we go?
undergo deformation in the process.
Absolutely correct. Students, हमें rigid body इसलिए लेना है कि हमें क्या समझना मालूम है जो भी students एक मुझे ध्यान I want to understand this कि जब भी हम ये rotational motion समझते students तो we are trying to put this into applications. Concept of rotational motion we are trying to put into applications in physics. Applications, that means practically it will go with respect to devices. Getting it, and which is brought into use into our day-to-day life. From here onwards we take it. अभी suppose मैं rotational motion के बारे में समझना हो तो मुझे rigid body ही चाहिए. Students, an elastic or plastic body will not help me out. क्योंकि rigid body होगा students, तो I want that angular speed to remain constant. Look at your ceiling fan at your home. Students, when you try to put the regulator onto a particular value, does the speed of the blades increases or then decreases, then sudden increase, sudden decrease, stops in between? Is the motions regular or irregular? regular motions. Look at the spinning drum of a washing machine. The rotational motion of the particular drum of the about a given axis is that when it's made to spin at a particular, what happens? It remains constant. Am I getting it? At times it doesn't increase or it doesn't decrease. It remains constant. It can be like that motion goes clockwise and anti-clockwise, but time for one half a revolution remains constant. Look at the mixer grinder. And students, jo kuch bhi, look at the wheels of the car when it is set to rotate, we consider. Are you getting it? At a particular constant speed, we can consider. So all these things, when you're speaking about students, we need to go for what kind of bodies? Rigid body. क्योंकि जब भी body को rotate करते हैं ना students, तो वहाँ पे एक external force की जरूरत है. Now suppose if I happen to give you three kind of objects, students, I'm giving you a rigid body, I'm giving you an elastic body, and I'm giving you a plastic body. All three objects are made to rotate about a given axis. But one of them is rigid, one of them is called elastic, and one is considered to be plastic. अगर ये तीनों को मुझे रोटेट कराना है तो मुझे क्या करना पड़ेगा सर? बाहर से आपको एक एक्सटर्नल फोर्स देना पड़ेगा, एक टैंजेंशियल फोर्स देना जरूरी है. So the body undergoes rotational motion. The body undergoes rotational motion. Getting it? It should rotate about given axis. I want it to rotate. तो यहाँ से मैं एक्सटर्नल फोर्स लूंगा. अगर मैंने एक्सटर्नल फोर्स लिया तो क्या होगा? अगर तुम उसको फोर्स अप्लाई करोगे तो क्या होगा? द बॉडी शुड नॉट अंडरगो डिफॉर्मेशन स्टूडेंट्स. और यहाँ पे डिफॉर्म नहीं होगा क्योंकि यहाँ पे स्टूडेंट्स ऑल द एटम्स एंड मॉलिक्यूल्स आर वेरी क्लोजली एंड कॉम्पैक्टली प्लेस्ड. Students, यहाँ पे atoms and molecules are very closely and compactly placed. So effect of force doesn't deform the body. And thereby the body can perform pure rotational motion. The best example we consider is the Earth. It's a dense matter inside it. We say that it's set to rotate about a given axis. As such in physics, students, in physics, I must have told the students when I did elasticity for those who are taking college lecture students. In physics, no object is perfectly elastic or rigid or plastic. No body is perfectly. We can give an example. तो ये rigid body है. Rigid body का मतलब क्या हुआ? Atoms and molecules are distributed very closely and compactly. तो यहाँ पे intermolecular space बहुत ही negligible है. तो यहाँ पे internal restoring फोर्स सबसे ज्यादा है, सबसे मैक्सिमम है. यानी अगर तुम बाहर से फोर्स अप्लाई बढ़ाओगे लेकिन अंदर का फोर्स उतना ही स्ट्रांग है, therefore the body does not undergo any deformation due to external deforming forces. And we need such kind of objects to understand rotational motion. So students, जब भी तुम प्रॉब्लम सॉल्व करोगे या डेरिवेशंस करोगे या कुछ भी करोगे तो तुम्हें दिया होगा a uniform rigid body. Every time they'll give you a uniform rigid body set to rotate about its central axis or about its axis of rotation passing through center of mass or passing through center of gravity. So you should go for rigid. क्योंकि यहाँ पे अगर मैंने elastic दे दिया तो क्या होगा? Body शायद अपना deformation, क्योंकि यहाँ पे how the atoms and molecules are slightly far away. यानी यहाँ पे intermolecular space थोड़ा सा ज्यादा है as compared to this. यहाँ पे intermolecular space बहुत ही ज्यादा है. तो ये body क्या होगा? ये body शायद permanent deformation भी हो सकता है. ये permanent deformation हो जाएगा. Students, this is permanent. A simple example, a plastic ball. Students, एक TT ball लो, TT ball को hard you hit it with a bat. What happens? It can change its shape permanently. Due to deforming forces. ये you go for an example of a rubber ball or a sponge ball, smileys. येलो कलर के स्माइली बॉल होता है. तो जब भी तुम उसको फोर्स लगाओ तो व्हाट हैपेंस? इट कैन चेंज इट्स शेप. लेकिन जैसे तुमने डिफॉर्मिंग फोर्सेस निकाल लिया तो वापस अपने ओरिजिनल पोजीशन पे आ गया. फॉर एग्जांपल, हैव यू सीन दोस पीपल हु डू पॉटरीज? ओके, क्ले लेते हैं, दे ट्राई टू पुट दैट मड क्ले स्टूडेंट्स एंड दे हैव अ रोटेशनल व्हील. Okay, they try to dump the mud clay onto it and then they give shapes to it. So what exactly it is? It's an elastic body. A dove we can consider. You can change its shape. लेकिन वो तुम्हें प्योर रोटेशनल मोशन नहीं दे सकता. ये तुम्हें प्योर रोटेशनल मोशन नहीं देगा. हमें हमें rotational motion के अंदर students our concept goes with pure rotational motion के हिसाब से तो we always go for what kind of body? Rigid body. So
Rigid
to
body.
understand rotational motion, a rigid body is a must. A rigid body is a must. This is very important. Now, what is a rigid body? अगर किसी ने पूछा तो तुम्हें ये बोलना internal intermolecular space is negligible. Intermolecular force of attraction is maximum. Thereby, internal restoring force is also maximum. Therefore, if I try to give an applied force externally, the body does not undergo change in its shape or size. Such bodies are called to be rigid body. But as such, in physics, is there any object called perfectly rigid, perfectly elastic, perfectly elastic? No. There is no object as called perfectly rigid. Can I erase the students?
Sir, what are plastic bodies?
Plastic body is a body which can undergo permanent deformation. या ना अगर सपोज मैं कभी कभार अगर मैं आता हूँ मेरा if I come at TV party and if I get my car and if you are very angry onto me all the time, okay, because you get very angry onto me and you want to remove my frustration, there are certain parts of the car which are fiber body. तो तुम क्या करोगे? आके ऐसे जोर से डम कर दिया, मेरी गाड़ी को ऐसे बैंग कर दिया, है ना प्लीज ऐसा मत करना. तो क्या हो गया? वो डिफॉर्म होगा कि नहीं होगा? है ना?
Yes.
परमानेंट डिफॉर्मेशन. हंस मत, है ना? ओके, डोंट लाफ. नेक्स्ट टाइम करूंगी, ऐसा मत सोचना. तो डिफॉर्म हो गया, परमानेंट डिफॉर्मेशन हो गया. हाँ, उसको वापस मुझे यूनिफॉर्म करने के लिए मुझे वापस चेंज करना पड़ेगा, डेंट एंड पेंटिंग का काम करना पड़ेगा. तो जो बॉडी को तुम परमानेंट डिफॉर्म कर सकते हो तो दोस आर कॉल्ड एज प्लास्टिक बॉडीज. एग्रीड?
Yes.
ओके. कैन आई इरेज इट स्टूडेंट्स? इरेज कर दूं मैं इसको?
Yes, sir.
Okay, now students, the first concept what you're speaking about in terms of rotational motion, students, we speak about torque and couple. Students, anybody can tell me what exactly torque is? Students, what exactly torque is? Since torque is simply called as moment of force, and this is pronounced as tau. It's a Greek alphabet. Students, torque is nothing but moment of force. Students, what exactly mean by the term moment? Students, what exactly mean by the term moment? I've told you this also in circle. The word moment stands for, students, turning effect. Since turning effect of a rigid uniform body due to application of a tangential force is called moment of force. Since turning effect of a rigid uniform body. Students, I'm restricting myself to rigid and a uniform body. Uniform ka matlab mass is uniformly distributed. Students, turning effect of a rigid uniform body due to what? Application of a tangential force is called moment of force. समझ में आ रहा है? The word only moment stands for turning effect. लेकिन ये टर्निंग इफेक्ट किसकी हिसाब से हो रहा है? एक फोर्स अप्लाई कर रहे हो ना, तो वो टर्निंग इफेक्ट ही होगा ना. फॉर एग्जांपल, इफ आई गिव यू सिंपल एग्जांपल स्टूडेंट्स, अगर मैं यहाँ पे तुम्हें एक रॉड दे दूं स्टूडेंट्स, एक रॉड दे दूं मैं, यूनिफॉर्म रॉड, ओके, जिसका लेंथ इज एल. स्टूडेंट्स, अगर ये रॉड एल है तो फिर एग्जैक्टली इट्स द सेंटर ऑफ मासेस. Its center of mass is geometrical center. Can I say this is actually, I can consider as my center of gravity also, students? What is center of gravity? Students, can you tell me what is center of gravity? Anybody? Students, what is center of gravity? Students, a point. हाँ, Tell me.
The point at which the weight of the entire body is concentrated.
Yes, the point at which the entire weight of the body is supposed to be concentrated. और उससे और अच्छी तरह से बोलना है तो क्या बोलना? Center of gravity is a point where the algebraic sum of total moment of force about that point is equal to 0. है ना? Therefore, the body can undergo equilibrium. This equilibrium can be static or can be dynamic. Which dynamic? Rotational dynamic. Students, center of gravity is a point where the entire weight of a body is supposed to be concentrated. Absolutely correct. Point where entire weight of a body is concentrated. है ना? ये हुआ center of gravity. Where the entire weight of a body is supposed to be concentrated. Can I consider that at that particular point, the summation of all the points about that point, summation of all the moment of forces about that point for that object is equal to 0? Thereby, what happens to the body? The body can maintain an equilibrium. Thereby, the body can undergo certain equilibrium. What kind of equilibrium? It can be static or rotational. Take a simple example of static, students. अगर मैंने static equilibrium बोलता तो students एक simple example मेरा static equilibrium का which you have learned in lower standard also. Students, a beam balance. Students, have you given an example of a beam balance or an equilibrium balance, students? है ना? अगर तुम beam balance लेते हो students, अगर तुमने beam balance लिया तो ये तुम्हारा rigid uniform beam है students. देखो where exactly center of gravity? So the center of gravity is exactly midway. So students, ये हुआ तुम्हारा knife edge. इसको हम बोलते हैं नाइफ एज. सर ये होगा हमारा एक्सिस ऑफ रोटेशन, इसको मैं बोलूंगा फुलक्रम. अभी देखो स्टूडेंट्स, ये सीसॉ या बीम बैलेंस या इक्विलिब्रियम बैलेंस, तो क्या ये रोटेट हो रहा है स्टूडेंट्स? नहीं हो रहा है, क्योंकि पूरे रॉड का वेट हमने कहाँ पे कॉन्सेंट्रेट कर दिया है? सर यहाँ पे कॉन्सेंट्रेट कर दिया. रो पॉइंट कौन सा है? सीजी है. सीजी क्या है? सेंटर ऑफ ग्रेविटी. यानी ये रॉड का कुछ मास है ना? उसका भी तो एक फोर्स एक्ट होता रहेगा. हाँ सर, इस तरह फोर्स एक्ट हो रहा है. सर ये रॉड का भी तो फोर्स एक्सर्ट हो रहा है. हाँ सर, ये भी तो फोर्स एक्सर्ट हो रहा है. अभी ये जो फोर्स है विच इज एक्टिंग एट 90 डिग्रीज टू द लेंथ ऑफ द रॉड, ये भी फोर्स एट 90 डिग्री. इसको हम पकड़ते हैं F1. ये बोलूंगा मैं डिस्टेंस R1, दैट इज द पोजीशन वेक्टर वी कंसीडर. दिस इज F2 and the position vector is R2. Can I say this is going to give me what kind of motion? This is going to give me what kind of motion? So it's going to give me anti-clockwise moments. ये कौन सा moments दे रहा है? Clockwise moments. लेकिन क्या body anti-clockwise जा रहा है? नहीं. क्या ये clockwise जा रहा है? नहीं जा रहा है. ये rest पे है. तो what kind of equilibrium is this? Is called static equilibrium. क्यों? क्योंकि algebraic sum of total moment of force about that point is equal to 0. Of course. Rotational dynamics में क्या होगा? Algebraic sum of net moment of force about that point is equal to 0, but still the body is moving with constant angular velocity, students. For example, we can say rotation of Earth about its axis. Does omega remains constant? Yes, sir. What kind of equilibrium is this called? Rotational equilibrium, students. The algebraic sum of total moment of force about that point is equal to 0. ये rotation equilibrium के लिए है. अगर तुमने blades of a ceiling fan एक constant speed से move किया तो rotation equilibrium है. Move हो रहा है, object move. यहाँ पे object rest पे है. यहाँ पे ऑब्जेक्ट मूव है, एग्जैक्टली आइडेंटिकल टू व्हाट यू हैव लर्नड इन लॉज ऑफ मोशन. Friends, you all must have learned in laws of motion about equilibrium. Summation of net force acting on the system is equal to 0. है ना?
Yes, sir.
एक सिंपल कंसेप्ट तुम लोगों ने पढ़ा होगा. ध्यान से देखना स्टूडेंट्स, एक सिंपल कंसेप्ट आई एम ट्राइंग टू पुट फॉरवर्ड स्टूडेंट्स. अगर कोई कार रोड के ऊपर जा रही है स्टूडेंट्स, है ना, तो अगर तुम्हारा अप्लाइड फोर्स इज ग्रेटर देन द फोर्स ऑफ फ्रिक्शन, हाँ स्टूडेंट्स, अगर तुम्हारा अप्लाइड फोर्स इज ग्रेटर देन द फोर्स ऑफ फ्रिक्शन, तो मुझे बताओ क्या मोशन एक्सेलरेटेड होगा? हाँ सर, मोशन इज एक्सेलरेटेड. क्योंकि एक्सेलरेशन का फॉर्मूला क्या होगा? अप्लाइड फोर्स माइनस फोर्स ऑफ फ्रिक्शन अपॉन मास ऑफ द बॉडी. तो एक्सेलरेशन पॉजिटिव होगा. अगर तुम्हारा अप्लाइड फोर्स इज लेस देन द फोर्स ऑफ फ्रिक्शन, तो एक्सेलरेशन क्या होगा? सो यहाँ पे एक्सेलरेशन पॉजिटिव होगा, यहाँ पे एक्सेलरेशन नेगेटिव होगा. मोशन इज गेटिंग रिटार्डेड. तो समझ में आ रहा है स्टूडेंट्स? यहाँ पे टायर पंक्चर हो गया. फॉर एग्जांपल, कार को तुम रोड पे जा रहे हो और ऑल ऑफ अ सडन टायर में से हवा निकल गई स्टूडेंट्स, तो तुम्हारा अप्लाइड फोर्स हो रहा है, लेकिन फ्रिक्शन भी तो साथ में हो रहा है ना, डिफ्लेट हो रहा है टायर. Are you getting it? And finally, the acceleration will be negative and the velocity will be brought to 0. If in case अगर मैंने बोला applied force is equal to the force of friction, यानी हुआ क्या है स्टूडेंट्स? ये कार है, तुम्हारा फोर्स अप्लाइड फोर्स फ्रिक्शन को बैलेंस कर रहा है. mg नॉर्मल रिएक्शन फोर्स को बैलेंस कर रहा है. तो कैन आई से दैट algebraic sum of forces along y axis is 0, algebraic sum of forces along x axis is equal to 0, summation of all the forces acting on equal to 0. But is the car at rest? Is a car at rest? No. यहाँ पे मैंने जब equate कर दिया, the car will be in motion, but in this case your acceleration is 0. The car is going with constant speed, uniform speed. स्टूडेंट्स ये पढ़ा है कि नहीं पढ़ा लॉज ऑफ मोशन में? हाँ स्टूडेंट्स.
Yes, sir.
तो वही काइनेमैटिक्स में जब भी मैंने पढ़ाया, तो वहां पे मैंने एफ के बारे में कुछ नहीं बोला था. मैंने वहां पे क्या बोला था? इफ फाइनल वेलोसिटी इज ग्रेटर देन इनिशियल वेलोसिटी, एक्सेलरेशन इज पॉजिटिव. If final velocity is less than initial velocity, acceleration is negative. If final velocity is equal to initial velocity, acceleration is 0. The body is going with constant velocity. लेकिन वही जब तुम लॉज ऑफ मोशन में आते हो, तो वहां पे कॉज ऑफ मोशन है फोर्स. तो तुमने पूरा फोर्स के हिसाब से ले लिया. अगर तुम्हारा अप्लाइड फोर्स फ्रिक्शन से ज्यादा होगा तो एक्सेलरेशन पॉजिटिव होगा. अप्लाइड फोर्स लेस देन फोर्स ऑफ फ्रिक्शन, तो एक्सेलरेशन नेगेटिव होगा. दोनों को इक्वेट करोगे तो एक्सेलरेशन 0 हो जाएगा. तो व्हाट एग्जैक्टली द बॉडी इज गोइंग विद यूनिफॉर्म, लेकिन समेशन ऑफ ऑल फोर्स. तो ये हुआ तुम्हारा स्टैटिक और यूनिफॉर्म डायनामिक्स भी कंसिडर. लेकिन ये ट्रांसलेशनल हुआ, हम रोटेशनल के बारे में बात करें. तो यहाँ पे जब ये v कांस्टेंट है, तो यहाँ पे ओमेगा कांस्टेंट होगा. यहाँ पे समेशन ऑफ f इज इक्वल टू 0, समेशन ऑफ टॉर्क इज इक्वल टू 0. So whenever somebody asks you students what exactly center of gravity, listen carefully. So center of gravity is a point which can lie inside the matter or can lie outside the matter also. ये भी ध्यान में रखें. Of course, for a thin uniform rod, center of gravity is a geometrical center. लेकिन इसी को मैंने ring कर दिया, तो very exactly center of gravity is at the center of the ring. If I happen to give you a boomerang, students, अगर मैंने boomerang दिया तुम्हें, students, for a boomerang, students, where exactly center of gravity is? Where is center of gravity? Center of gravity कहाँ पे होगा? So center of gravity will be the point lying outside the system. ये होगा तुम्हारा center of gravity for a boomerang. It's a point lying outside the matter. And center of gravity is independent of the position of the body. Whatever may be the position of the body, the force will be always directed from the center of gravity towards the center of the earth only, students, vertically down. See, हमेशा ध्यान में रखें. So center of gravity is a point we can consider which can lie inside or outside the matter. It's independent of the position of the body, students, we consider. It is a point where the entire weight of a body is supposed to be concentrated. It is also considered to be the algebraic sum of the total moment of force about that point is equal to 0. Thereby, the body can undergo static equilibrium or can have rotational equilibrium, we consider, students. In case of static equilibrium, give an example of a beam balance. Rotational equilibrium can give an example of the earth rotating about its own axis. For earth rotating about its own axis, students, omega all the time remains constant. Can you give me the value of omega? ये भी मैं बता सकता हूँ. स्टूडेंट्स, रोटेशनल मैंने बताया आगे, ओमेगा रिमेनिंग कांस्टेंट, तो यहाँ पे यूसीएम के हिसाब से जाओगे, तो ओमेगा को क्या तुम d थीटा बाई dt लिखोगे या 2 पाई बाई t लिखोगे?
Pi by t.
2 pi by
2 pi by t kitna hoga? 6.28. What is time taken for Earth to complete one rotation? 1 day corresponds to 86,400 seconds. Students, you see constant value hogi 7.26 into 10 to the power of minus 5 radian second inverse. Around 7 students into 10 to the power of minus 5. ये ध्यान में रखना students. Omega remains constant. So students, what is torque? Torque is a vector quantity, and torque is simply, students, when you have learned it in the lower standards, how is torque defined as? Torque is defined as the product of momentum and the force applied. Why am I writing R cross F? Why am I not writing F cross R? Because we're speaking about anti-clockwise. R cross F using right hand screw rule. So torque is the product of momentum and application of force. What are the factors on which torque depends? It depends on the momentum. It depends on the magnitude of force applied. Does it depend on the position of the axis of rotation? Yes. Does it depend on the point of application of force? Yes. अलग-अलग point पे तुम्हें अलग-अलग torque मिलेगा. यानी indirectly मैं R और F के बारे में बात कर रहा हूँ. So students, torque is given by the formula R cross F. What exactly its SI unit we consider is? SI unit is Newton meter, students. ये ध्यान में रखना. And 1 Newton meter is equal to how many dyne centimeter? So students, 10⁻⁷. Because Newton meter is joule. Dyne centimeter. Students, work, energy, torque. Work, energy, torque. All three are dimensionally same. Students, all three are equivalent, but they are not equal. Work measured in joules. Agreed. We consider energy is also it's assigned as joule. But if in case if I happen to consider torque, it's Newton meter we consider, and not always joule we consider. Agreed. So they are dimensionally correct. And 1 Newton meter is 10⁷ dyne centimeter. Are you clear, students?
Yes.
So what is the value that you have written under the rotational dynamic?
I've written the angular velocity of the Earth. The Earth is rotating about its own axis, and it has a constant angular speed, 7.26 into 10 to the power of minus 5 radian per second. Angular velocity of Earth rotating about its own axis, students, is 7.26 into 10 to the power of minus 5 radian per second. And it remains constant. Can I erase it now, students?
No, sir, wait. Yes, sir, done.
Okay. So let us consider this as the axis of rotation. Okay, this is the axis of rotation of a uniform of a rigid body. Uniform rigid body. Students, it's not a symmetrical body. It's asymmetrical, but it's uniform. Mass is uniformly distributed, students. अगर तुम देखोगे स्टूडेंट ज्यादा मास कहाँ पे डिस्ट्रीब्यूटेड होगा, यहाँ पे, तो स्टूडेंट्स इसका सेंटर ऑफ मास, सेंटर ऑफ ग्रेविटी यहाँ पे होगा. यानी स्टूडेंट्स अगर ये पूरे ऑब्जेक्ट को मुझे स्टेबलाइज करना है, स्टूडेंट्स अगर मैं यही डायग्राम में यहाँ पे ड्रॉ करूँ, just almost a kind of a replica. Hope it gets exactly same. अगर मैं एक आइडेंटिकल ऑब्जेक्ट यहाँ पे भी ले लूँ स्टूडेंट्स, ऑलमोस्ट सेम स्टूडेंट्स, तो मेरा सेंटर ऑफ मास यहाँ पे होगा स्टूडेंट, सेंटर ऑफ ग्रेविटी यहाँ पे होगा. I get it? A point where the entire weight of a body is supposed to be concentrated. यानी अगर मैंने इसको assume करूँ मैं कि अगर मैंने ये पूरे ऑब्जेक्ट को एक ऐसे नाइफ एज पे रख दूं स्टूडेंट्स, तो क्या होगा? What exactly it is? ये मेरा फलक्रम है ना? So students, see, this is the axis and this is your equilibrium, है ना? Since it's a uniform distribution, students, the entire system, it's a plane surface, it's a plane lamina, uniform. So can I say and it's a rigid body. Rigid body means all the atoms and molecules are closely. Suppose अगर मैंने यहाँ पे एक लिया है, इसके बाजू में नजदीक होगा, यहाँ पे होगा, यहाँ पे होगा. Students, यानी देखो अलग-अलग particles होंगे students. तो हर एक का अगर मैंने इसको M1 लिया तो उसका वेट नीचे की तरफ आएगा. तो यहाँ पे अगर मैंने M2 लिया तो उसका वेट नीचे की तरफ आएगा. यहाँ पे मैंने M3 लिया तो उसका वेट नीचे की तरफ आएगा. यहाँ पे लिया तो उसका वेट आएगा Mn. So these are all weights which are going to act in the downward direction, students. M into G. ये सारे वेट्स बना के क्या बन जाते हैं? ये क्या बनाएंगे सर? ये सारे फोर्सेस बना के एक टॉर्क क्रिएट करेगा. और वो टॉर्क कौन से डायरेक्शन में जा रहा है? ये टॉर्क कौन से डायरेक्शन में जा रहा है? So this torque is going in what direction? Torque in anti-clockwise direction. जो कि हम क्या लेते हैं? पॉजिटिव लेते हैं as per the sign conventions. और ये जो सारे फोर्सेस है, ये सारे फोर्सेस नीचे की तरफ जा रहे हैं. ये सारे फोर्सेस किस तरफ जा रहे हैं? ये अगर तुम देखो तो ये सारे फोर्सेस किस तरफ जा रहे हैं? फिर ये सारे जा रहे हैं क्लॉकवाइज के लिए. तो ये क्या होगा? टॉर्क इन क्लॉकवाइज डायरेक्शन. क्लॉकवाइज डायरेक्शन का मोमेंट ऑफ फोर्स क्या लेते हैं? नेगेटिव की वेक्टर है. तो ये हुआ इसका वेक्टर, है ना? ये पॉजिटिव और नेगेटिव. लेकिन क्या ये बॉडी इक्विलिब्रियम में है? यस. यानी टॉर्क इन एंटी क्लॉकवाइज डायरेक्शन. ओके, ये लेता हूं मैं 1 और ये लेता हूं मैं 2 इज एग्जैक्टली इक्वल टू टॉर्क इन क्लॉकवाइज डायरेक्शन. ये देखो, ये पॉजिटिव साइन बताते कि एंटी क्लॉकवाइज है, नेगेटिव बताते क्लॉकवाइज. इसको मैं यहाँ पे ले लूं तो कहने से टॉर्क 1 प्लस टॉर्क 2 इज इक्वल टू 0. तो कहने से algebraic sum of net torque about the system or about point C G about center of gravity is equal to 0, which can I say the body is going to have what kind of equilibrium? Static equilibrium. क्या ये क्लियर हुआ स्टूडेंट्स? Students, is it clear?
Yes, sir.
Every particle is at a certain distance. Because all particles are at certain distance from the axis of rotation. Students, all these particles are at different distances from the axis of rotation. This is axis of rotation. तो सबका वेट नीचे की तरफ फैक्टर हो रहा है. ओके, तो ये तुम्हारा एक कंसेप्ट आ गया. एंटी क्लॉकवाइज आई टोल्ड यू इज पॉजिटिव, और ये लुकिंग एट द रोटेशन ऑफ द अर्थ. स्टूडेंट्स, फिजिसिस्ट कंसिडर्ड एज अ कन्वेंशंस. नाउ व्हेन आई स्पीक अबाउट मोमेंट ऑफ फोर्स, स्टूडेंट्स, आई वाज स्पीकिंग अबाउट मोमेंट ऑफ फोर्स. ये ध्यान में रखना स्टूडेंट्स कि अगर मैं कंटिन्यूअस डिस्ट्रीब्यूशन ऑफ मास होगा ना स्टूडेंट्स, इफ देयर इज कंटिन्यूअस डिस्ट्रीब्यूशन ऑफ मास, for continuous distribution of mass, since it will be integration of dm and that will be equal to capital M. ये हमेशा ध्यान में रखना. Students, the mass is always integration of dm, and that will be equal to m. Okay. Now we speak about moment of force. Moment of force के बारे में हम लोग पता करें तो that will be tau. Okay. Now please pay attention, students. Think as if this is your point of rotation. We consider this is the axis of rotation, students. Now let us say that I'm trying to apply a force, students. Okay. In this direction. Okay. And that force is made to act in this direction. ये तुम्हारा force है, students. I'm making it to this. ये जो तुम्हारा position vector इस direction में जा रहा है. मुझे बताओ students, अगर ये मेरा line of action of force है, students, ये है line of action of force. Okay, and this line of action of force, it forms an angle theta with the position vector. Students, will the body will undergo maximum turning effect, or will the turning effect will be less? Look at a line of action of force and the position vector, and this is point P. Point P, point of application of force. Students, so is my torque will be maximum or it will be less? It cannot be minimum, it is less. So will it be maximum or less? Students?
It will be maximum.
It will be less, not maximum. Students, to have maximum, what exactly my component should be? Theta should be
90 degree.
90 degree.
अगर सपोज मैं ये पोजीशन वेक्टर को थोड़ा सा आगे ले लेता हूँ, कहना है ये थीटा, तो कहने से ये भी मेरा थीटा हो जाएगा. फ्रेंड्स, कैन आई रिजॉल्व माय आर इनटू एफ इनटू टू कंपोनेंट्स? तो ये देखो ये क्या हो जाएगा सर, ये आपका हो जाएगा एफ कॉस थीटा. अभी ये देखो, इज दिस इज एफ साइन थीटा. स्टूडेंट्स, yes, it is f sin theta. Students, now when you look over here, is your f sin theta is in the direction perpendicular? Yes, it's going in this direction. आया ना? ये तुम्हारा एक कंपोनेंट हो गया परपेंडिकुलर और एक हो गया अलोंग. ये जो अलोंग है will not give any turning effect, students. ये देखो तुम्हारा पोजीशन वेक्टर r इस तरफ जा रहा है, तुम्हारा f cos थीटा भी इस तरफ जा रहा है. Students, अगर f cos थीटा और r एक ही डायरेक्शन में, तो ये कौन सा मोशन होगा? ये ट्रांसलेशनल मोशन होगा. आया ना? स्टूडेंट्स,
Yes.
लेकिन हमें रोटेशनल समझना है स्टूडेंट्स. तो हमें रोटेशनल के लिए कौन सा फोर्स लेना है? हमें ये नहीं लेना है स्टूडेंट्स. वी हैव टू गो फॉर एफ साइन. तो कैन आई से माय टॉर्क इज सिंपली एज आर एफ sin theta. So we need to go for component of theta. And what is theta? Theta is an angle between R and F. R and F. What is angle? Angle between two vectors. It's either angle between two heads or angle between two tails. So what is the way to write on R torque as RF sin theta? What is the correct way of putting in vector notations we consider? Then correct way of writing we can consider would be torque is equal to what? R cross F. Because now for rotational motion we consider torque is equal to what? RF sin theta. Are you getting? अगर ये थीटा मेरा 90 हो जाता है स्टूडेंट्स, अगर if I say my theta tends to be 90 in that case, so my line of action of force will be perpendicular, the torque will be maximum. Is this clear, students? Students, is it clear?
Yes, sir.
यानी पहले केस में तुम्हारे ये देखो ये ट्रांसलेशन मिल रहा है और ये रोटेशनल के लिए, तो रोटेशनल के लिए तुम्हें कौन सा कंपोनेंट यूज करना पड़ेगा? सर, वी हैव टू गो फॉर sin theta. That is it's a cross product, students. Torque is R cross F. The component is sin theta. When exactly torque is maximum? Torque is maximum, students. Torque is maximum when theta is 90 degree. Agreed? Yani pi by 2. Students, 1 pi by 2 is plus 1, 3 pi by 2 is minus 1. It's only the direction I'm considering it. But the theta will be 90 degrees. Students, torque is maximum. When exactly torque is minimum? When theta is either 0 or 180 degrees. Students. एग्रीड. साइन ऑफ 0 0, साइन ऑफ 180 is 0. तो ये हुआ तुम्हारा मिनिमम और ये हुआ तुम्हारा मैक्सिमम. Can I erase this part?
No, sorry.
Students, hope you all are getting it. Sparsh, are you getting it? Sparsh, are you there? Adarshni?
Yes, sir.
Okay. Udit is always ready. Tisha? Tisha and Swati, never you all reply. Tisha and Swati, are you all there? समझ
Yes,
में आ रहा
sir.
है? Okay.
Sir,
प्रियंका, हाँ बोलो.
below what you have written besides static equilibrium?
This is anti-clockwise direction. This is clockwise direction, minus sign.
That
And
of CG.
the algebraic sum of torque about center of gravity is equal to 0. Got it?
Yes. Done.
Okay. Friends. Now, students, when somebody gives you the formula for torque is simply we consider is a cross product of momentum and the force applied. Students. Okay, so when you speak about moment of force, R cross F, RF sine theta, unit, Newton meter. Students, one can also write on in terms of gravitational units. Students, यहाँ पे gravitational units की problem ज़्यादा पूछ सकते हैं. तो अगर मैं gravitational units के हिसाब से जाऊँ students, तो ये भी ध्यान में रखना. Students, gravitational unit के हिसाब से अगर मैं जाऊँगा तो ये होगा किलोग्राम फोर्स मीटर और ग्राम फोर्स सेंटीमीटर. Students, ये ध्यान में रखना 1 kilogram force is 9.8 Newton and 1 gram force is 980 dynes. Please do take care of this. यानी जब भी तुम MCQs करोगे तो 1 किलोग्राम फोर्स को नियरली इक्वल टू 10 न्यूटन ले सकते हो जब भी मल्टीपल चॉइस क्वेश्चंस करते हो स्टूडेंट्स. बोर्ड्स में 9.8 ही लेना है स्टूडेंट. तो 1 किलोग्राम फोर्स मीटर, getting it? It's equal to 9.8 न्यूटन मीटर और ये क्या हो जाएगा 989 centimeter. Do take care when you're solving problems based on 2 kilogram force and gram force. Now, students, when I speak about for moment of force, I said it about R cross F. Now, take a simple example of a door. Students, if I say what are the factors? What are the factors on which your moment of force depends? तो मैंने क्या बोला? It depends on the two factors. इसका formula में R cross F आया. So it depends on to R, it depends on to F. That means it depends on the point of application of force. And indirectly, it's speaking about position from the axis of rotation. And it also depends on the axis of rotation. So हम सबसे पहले axis of rotation के बारे में बात करते हैं students. सोचो कि एक rigid door है. This is I'll consider as a rigid, okay, door. और उसको मुझे rotate करना है, मुझे खोलना है. So students, I can have one axis passing exactly through its center. तो ये हुआ तुम्हारा एक्सिस ऑफ सिमेट्री के हिसाब से. दूसरा एक्सिस I can take it in this way at one end. Agreed? And the entire system can be rotated. There are two axes of rotation. So can I have my different axis of rotation, students? अगर मैंने different axis यानी पूरा door ये आधा आधा उस तरफ जाएगा आधा लेकिन खुलेगा तो जरूर. But will you get enough space for you to enter inside? अगर तुम्हें goods अंदर लेके जाना है, students, if you अगर तुम्हें goods लेके जाना है तो this is halfway and the other halfway. You can't let heavy goods to enter inside. So practically speaking कि तुम्हारे need के ऊपर है कि तुम्हें कहाँ पे access रखना है. So normally when you look into restaurants or somewhere into hotels or motels जहाँ पे तुम्हें one way in, other way is out, people go in and only for people transit in and out, like getting it, or into shopping malls or shopping complex or somewhere or the other, they have a door and it is made to rotate. तुम यहाँ से जाओगे तो वहाँ से कोई बाहर भी आ सकता है. It's like that either way. So that is an axis of rotation we consider. लेकिन तुम्हारा force यहाँ पे क्या apply हो रहा है? सर यहाँ का force यानी यहाँ पे apply हो रहा है, यहाँ पे भी force यहाँ पे apply हो सकता है. Either way you can consider. Agreed? So it depends on the axis of rotation. Second case, अगर suppose मैंने axis of rotation form same रखा students, the same door I want to open it, but now I've kept the axis of rotation over here. This is my axis of rotation of the door. Agreed? These are the hinges. For example, घर के अंदर ही दरवाजे देखो ना students, ये तुम्हारा ऐसा hinges है. I getting it? Maybe there are 3 hinges or 4 hinges at the side. Students, ये वाला होगा, ये center में होगा. You might come across center. You might having 3 and 3, 6. I'm getting it. So one is at the center we consider. Now, if I happen to go for it, students, where is the center of gravity of this particular entire door? So the center of gravity is over here. The geometrical center, point of intersection of the diagonals. ये तुम्हारा axis of rotation हुआ, students. तो ये तुम्हारा turning point हुआ, students. ये जो point P है, ये तुम्हारा turning point. Okay. Or we consider as by what point we consider, or rotating point I'll consider. Now if I want to apply force, तो मैं कहाँ पे force apply करूँगा? Friends, I'm giving you 3 such places. Can I apply force at point 1? Can I apply force at point 2? Can I apply force at point 3? Students, where should be the force applied in order to open the door effectively?
3.
Point 3.
Point 3. यानी अगर मैंने 1 से किया तो कहने से मेरा मोमेंटम कम हो जाएगा. यहाँ पे मेरा मोमेंटम और बढ़ेगा. यहाँ पे मैं लूंगा तो मोमेंटम सबसे ज्यादा होगा स्टूडेंट्स. So my point of application of force should be where? At point 3. So my turning point, yani students, longest the momentum, students, momentum का मतलब turning arm, longest the momentum, okay, better is turning effect. Less is the magnitude of force applied. Agreed? Students, मुझे अगर ये डोर को खोलना है तो अगर मैं अगर हैंडल 1 पे बिठाऊंगा तो क्या खुल सकता है? होगा ना, क्यों नहीं? लेकिन you need a really amount of good biceps and triceps and forearms to open it. You should be a really good, physically strong. Can I open the door if I keep the handle at point 2? Yes, but you still need that good strength. If I keep the handle at point 3, will you be able to do? Yes, we'll be able to open the door more easily. Even a kid can open the door if I keep and if the height is proper enough. So over here only one we consider. यानी अगर पॉइंट पे 3 पे ले लिया तो क्या हुआ, मेरा टर्निंग आर्म जितना लंबा होगा उतना मेरा मैग्नीट्यूड ऑफ फोर्स कम हो जाएगा स्टूडेंट्स. और अगर मेरा ये कम होगा तो मैग्नीट्यूड ऑफ फोर्स बढ़ जाएगा. So how exactly R and F inverse variation? So what are the factors on which moment of force depends? It depends on the momentum and it depends on the magnitude of force applied. Does it depend on the position of the axis of rotation? Yes, it also depends on the axis of rotation also. What are the point of applications? Point 1 is point of application. Point 2 is point of application. Point 3 is point of application. Which is the best point? Point 3. at what angle the force should be applied? So तुम बोलोगे sir, the force should be applied at an angle of 90 degree. So this I'll consider at 90 degree. Sine of 90, if I happen to consider, will give me maximum torque. Turning effect will be maximum. Is this clear, students? So is it clear?
Yes.
Can I erase it
Yes,
now?
sir.
Erase कर दूं इसको? Erase करूं, students?
Yes, sir.
Do keep gravitational units proper, students. 1 kilogram force is 9.8 Newton. 1 gram force is equal to 980. Now, students, let us go for a few problems onto it. Students, this is a screw, okay? And I want to remove the screw, okay? It's exactly identical screw. But now I'm using two spanners as such. Okay, those spanner layouts. I'm taking two spanners. ये पहला वाला एक स्पैनर है. The second part of the spanner. But in one of the spanner, students, I've taken the length to be smaller. और दूसरे के लिए मैंने लेंथ थोड़ा सा बड़ा कर दिया है. Okay. So it's the same screw nut is there. I want to open this particular screw nut, students. I want to perform work. In the first case, the distance of the spanner is 20 centimeters, students. The length of the spanner is 20 centimeters, students. And in the second case is 60 centimeters. Okay. In order to open the nut of the spanner, students, this is case one, this is case two. What should be my force applied in the second case? If the force applied in the first case is given to me as 5 kilogram force. So what is the magnitude of force applied in the second case? For a spanner of length 60 centimeter to open a nut, okay, if an identical nut can be opened by a force of 5 kilogram force, length 20 centimeter. So is the question clear? Since question clear hai?
Yes.
So could you please repeat?
A force of 5 kilogram force can open a nut of force of 5 kilogram force can open a nut if a spanner of length 20 centimeter is used. What force is required for the same nut to be opened if the length of the spanner is 60 centimeter? Both are identical nut, students. Yes, anyone? Students, is it the same nut? Students, is it the same nut? Yes or no?
Yes, sir.
Yes, sir.
तो उसको जो फिक्सिंग मिला है ग्रूव के अंदर, तो it has been bound by the same contact in that case. अगर उसको मुझे खोलना है, तो what about the work done in both the cases? What is the work done in both the cases? It is just simply to unwind the nut, है ना? So the necessary torque required for it to rotate should be same. Students, in order to have a turning effect, okay, or in order to open the nut, students, the answer is no. Because in both the cases, it's the nut is same. Students, if the nut is same, then the amount of turning effect required to open the nut should be same. So turning effect in the first case, students, turning effect in the first case, should it be different as compared to turning effect in the second case for the same nut? हाँ बताओ.
No, sir.
No,
वही सेम. अगर सिंपल एग्जांपल, एक स्क्रू है स्टूडेंट्स, एक अच्छा सा स्क्रू है और वो स्क्रू को तुमने एक सिस्टम में फिक्स करके रखा हुआ है और तुम्हें 2 स्पैनर दिए, तो स्टूडेंट्स उसका जो ग्रूव है, उसका बाइंडिंग है, उसको अनवाइंड करने के लिए तो यू नीड दैट मच अमाउंट ऑफ टॉर्क इटसेल्फ ओनली. लेकिन वो टॉर्क को तुम्हारा जो अप्लाइड फोर्स है वो ज्यादा होना चाहिए, कम होना चाहिए, वो किसके ऊपर डिपेंड होगा? स्पैनर के लेंथ के ऊपर डिपेंड होगा. Students, for the same spanner, you have to make it very clear, for same screw nut. Are you getting it? You need same torque in order to unwind. Agreed? Now part B is correct. So in the first case, can I say torque in the first case will be R1 F1? Of course, look at the force. अगर मैं यहाँ पे force apply करूँगा तो students मेरा force ये 90 है. यहाँ पे मेरा force F2 होगा students, and this is also 90. ये R2 होगा position vector, ये R1 होगा. One force into perpendicular distance, theta is 90 over here, torque is maximum. यहाँ पे भी theta is 90, torque is maximum. So R1 F1 is R2 F2. मुझे क्या चाहिए? F2 चाहिए. तो am I getting my answer? R1 F1 by R2. What is F2? How much is R1 given to me? It's 20 into 5 divided by 60. What exactly F2 will be equal to cancellation? 2 3s are 5 by 3. That will be equal to 1.67 kilogram force. Is that clear? Students, क्या ये clear हुआ?
हाँ सर.
अभी देखो लंबा हुआ स्पैनर, स्पैनर का लेंथ जब मैंने लंबा कर दिया, देखो कितना फोर्स अप्लाई करना पड़ रहा है. स्टूडेंट्स, पहले कितना फोर्स अप्लाई करना पड़ता था उसको खोलने के लिए, है ना? यू नीड गुड स्ट्रेंथ, you need a more external force for it to open the nut. लेकिन यहाँ पे थोड़ा सा लंबा स्पैनर होने की वजह से क्या हुआ, देखो तुम्हारा फोर्स कितना डिक्रीज हुआ, 1.67 kilogram force, so that you can easily open it. That is why you must have come across a screw jack. Students, do you know what exactly a screw jack is? A jack screw or a screw jack. A jack is normally a spring action का. Students, पूरी तुम्हारी जो कार है उसको तुम लिफ्ट कर सकते हो by simply a small kid can do it. अगर जब भी लॉन्ग डिस्टेंस के ऊपर तुम्हारा टायर्स पंक्चर होते हैं तो एवरी व्हीकल के साथ में दे प्रोवाइड विद जैक स्क्रू. तो जैक स्क्रू को नीचे की तरफ रखते हैं, हमेशा टायर के नजदीक स्टूडेंट्स एक थोड़ा सा स्पेस दिया जाता है. अगर जब भी कार स्टेशनरी हो, हैंड ब्रेक्स ऑन हो, तो ट्राई टू जस्ट टेक योर हैंड क्लोजर टू द टायर्स. तो वहां पे ऐसा स्क्वायर शेप कलर का एक ऐसा फ्रेम होगा, एंड दैट इज अ फ्रेम वेयर द जैक हैज टू बी प्लेस्ड. और फिर उसके अंदर you try to put a rod inside it and that rod is longer and you just go on rotating it. जैसे तुम rotate करोगे तो what happens, तो spring action की वजह से jack खुलेगा and the entire car can be lifted against gravity. You can lie down also under it. It's like that. So even a small kid can also lift the car, you can say. So this is what the concept speaking about of moment of force. क्या ये clear हुआ students?
Yes, sir.
Yes, sir.
Can I erase this?
Yes, sir.
Okay. Since it's a rigid uniform laminar is given to you, okay, and this is what the center of gravity I'll consider, okay, the point where the entire weight of the body is supposed to be concentrated. Okay. Now at this particular point, students, there are certain forces acting, okay, at different distances, students. So if in case if I happen to go for one force is acting in this direction, its position vector is R1, okay, and that is equal to 1 centimeter. Force F1 is equal to 6 Newton, students. Okay. Then another force is acting over here, students. Its position vector from here I'll consider will be equal to 4 centimeters. Students, let me take this as 2 centimeter. Agreed. And your force F2 is acting as how much? 5 root 3 Newton, students. Okay. The third force is acting, students. This is one. And this is 10 root 3 Newton. Okay. And the position vector is acting in this direction. This is R1, this is R2, this is R3, this is F3. Okay. And this I'm giving you as 3 centimeter. 120 degrees. Okay, this angle is 120 degrees. The last force is acting in this direction, students. And this is the position vector of the force. This is R4. And this F4 is acting, students, 3 root 3 Newton. My question is, students, there are forces acting. F1, F2, F3, F4 are acting at different points, students, for a rigid uniform lamina, students. And this is my axis of rotation. My question is, students, find out the magnitude and direction of turning effect. Is the question clear, students? I want to find out magnitude and direction of turning effect. This question clear हुआ?
Yes, sir.
F1 6 Newton, R1 1 centimeter, F2 5 Newton, R2 2 centimeter, F3 10 to 3 Newton, R3 3 centimeter, forming an angle of 120 degrees, students. Okay, ये है तुम्हारा axis of revolution. ये तुम्हारा axis of revolution, rotation. Sorry. F4 is acting in this direction, and R4 is given to you as. I didn't give you R4. Okay, let me take this as 4 Newton, 4 centimeters. R4. Hope the question is clear. Students, सबको question समझ में आया?
Yes, sir.
Yes, sir.
I want to find the magnetic direction of the turning effect, students. And all these forces are along, students. All these forces are along the plane lamina. Students, ये मैंने top view दिया है. Students, ये सोचो कि मैंने ऐसा top view दिया है, ऊपर से दिखा रहा हूँ मैं. Your horizontal lamina है. Am I getting it? And all these forces are acting along the lamina. Sorry, this is 10, huh? Not 10 to 3. Very sorry. ये 10 Newton है, students, please. F3 is 10 Newton, everyone. Please, F3 is 10 Newton, huh? Not 10 root 3. This is 5 root 3. This is 10 Newton. This is 3 root 3. This is 6 Newton. Yes, anyone? क्या बात है? Jana is the first one to answer, students. Yes, anybody else? Yes, Jana. Can you answer, Jana? कैसा आया? What is the answer?
Sir, we will find the moment of force for, to say torque for all the forces.
Okay, so we need to find out magnitude and direction. So you'll find out net torque acting on the system. So the net torque acting on the system is torque 1 plus torque 2 plus torque 3 plus torque 4. And torque is given by the formula R F
Sin theta.
Okay, fine. Now what about torque 1?
Torque 1 will be 0. Because sine it is 0 degree, so it has to be 0.
So you are mute. You are muted.
Sorry. Since torque 1 is equal to what? F1 R1, the angle between F1 and R1 is 0 degree. Both of them are acting in the same direction, students. So sine of 0 will be equal to 0. So torque 1 will be equal to 0. Agreed?
Yes, sir.
Yes.
Okay. Yes, Jana. For the second one, क्या करोगे तुम?
Second one, the angle has to be 90 degrees.
Yes, we need to, if I'm not giving you, and if you happen to look at the diagram and if you take theta is equal to 90, the torque will be maximum. So यहाँ पे क्या होगा? F2 into R2. So F2 into R2 will be equal to how much? 5 2s are 10. So it will be 10 root 3. 10 root 3 Newton centimeter. Agreed? Is it clockwise or anti-clockwise? 10 root 3.
Anti-clockwise.
ये motion इस तरफ देगा तो anti-clockwise. That's why anti-clockwise movements are positive. Students ये भी ध्यान रखना. Plus torque 3. Look at torque 3. 3 के लिए क्या करोगे?
For 3, the theta is 120 degrees. So we will do Fs sin theta.
Okay. Students, we consider the angle between the two. We consider is sine of 120. Sine of 120 will be equal to how much?
It's root 3 by 2.
Okay. यानी स्टूडेंट्स अगर तुम फोर्सेस के हिसाब से जाओगे तो अगर यही फोर्स को मैं आगे कंटिन्यू कर दूं आंसर सुना स्टूडेंट्स तो वी कैन गो फॉर इट्स कंपोनेंट. ये देखो ना ये फोर्स को मैंने आगे कर दिया. अभी मैं एक्सिस को निकाल देता हूं स्टूडेंट्स सो दैट इट शुड नॉट गेट कंफ्यूज्ड विद एनी अदर लाइन. स्टूडेंट्स अभी देखो ये फोर्स को अगर मैंने यहाँ पे ले लिया स्टूडेंट्स तो इसी का एक हॉरिजॉन्टल और ये हो जाएगा वर्टिकल स्टूडेंट्स है ना. ये 20 तो ये 60 हो जाएगा. तो ये क्या बन गया स्टूडेंट्स? F cos 60 F sin 60. Look over here, F sin 60 and position vector. Students, are they perpendicular? Yes, we consider. So F sin 60 is tangential, we consider. तो यहाँ पे तुम्हारा क्या होगा स्टूडेंट्स? It is 10 into 3. Sin of 60 is root 3 by 2. So what's the answer? 15 root 3 Newton centimeter. You got 15?
Yes.
What is the motion? Is the motion still clockwise? Anti-clockwise. इसी डायरेक्शन में मूव हो रहा है स्टूडेंट्स. यानी ये दोनों ऐड हो जाएगा तो प्लस 15 root 3 Newton centimeter. What about torque 4?
The torque 4 is again 90 degrees.
Yes. I'll take this as 90.
12 root 3.
Okay, so that will be plus 12 root 3 Newton centimeter. So the total net torque acting on the system will be equal to how much? 10, 20, 30,
37,
35,
root 3.
36, 37, root 3 Newton centimeter. That is 37 root 3 into 10 raised to minus 2 Newton meter. This is a motion clockwise. Is my answer in positive? Is my answer in positive? Yes. That means the system is moving in what direction? It's moving in anti-clockwise direction. क्या ये clear हुआ students? Students, is this clear to all of you all? अगर सपोज मैंने इसका डायरेक्शन चेंज किया होता तो एक नेगेटिव आ जाता। स्टूडेंट्स ये भी ध्यान में रखना, अगर इसको मैंने एक डायरेक्शन तो ये कौन से डायरेक्शन में जाता? क्लॉकवाइज जाता। स्टूडेंट्स क्लॉकवाइज आता तो ये मैं माइनस में लेता, ये भी ध्यान में रखना। स्टूडेंट्स अभी डायरेक्शन पूछा तो बिकॉज दीज आर टॉट्स वी कंसीडर दीज आर वेक्टर क्वांटिटीज। स्टूडेंट्स वेक्टर क्वांटिटी में पॉजिटिव और नेगेटिव साइन यही दिखाता है कि मोशन किस तरफ है। अगर सपोज दो नेगेटिव होता और एक पॉजिटिव होता, फाइनल आंसर मेरा नेगेटिव होता, उसका मतलब the system is set to rotate in clockwise direction. But if I get my final answer in positive, that means the entire rigid body is set to rotate in anti-clockwise direction. Anti-clockwise movements, we consider torque will be along positive axis. Clockwise movements, torque will be along the negative axis. So we as students, we take it that the entire system is set to move in anti-clockwise. Magnitude 37 root 3 into 10 raised to minus 2 Newton meter. Can I erase this, students? Erase कर दूं, students?
Yes, sir.
Okay. So students, today we have worked out with rotational motion. Students, I gave you about concept of rigid, elastic, plastic body. I gave you about all the rotational terms, angular terms, students, and the linear terms along which axis they are set to act. Their vector forms in that case. For a rotational motion, how the constituent particles are. What are the particles which are away from the axis, closer to the axis? Which term changes and which terms remains constant? Okay, that all I made it very clear with you all. Then I told you about moment of force, its formula, its sign conventions, anti-clockwise positive, clockwise negative. Friends, next lecture will be continuing further ahead with couple, and then certain more problems onto that, and then we go for your moment of mass, moment of inertia concept, and then your derivations of rigid objects. The way we went, students, for center of mass for a thin uniform ring, we use integration, exactly identical type of questions. Okay, students, next lecture will be continuing further on. Okay.
Okay, sir.
Bye.
Thank you.